Jono, how's the investing going? What did you get up to after Chad?
Got into lithium, Kev?
Lithium? Is that some new cryptocurrency?
Nah, crypto's for loons. No underpinning value. I mean the metal, for batteries and stuff.
Oh, that lithium. Didn't Nirvana sing about it? Is it going to the moon?
Right now? Yeah. Tripled my money in 6 months before last week's market correction. Still at 2x after it. And I'm nowhere near ready to exit yet. Be on for 10x if all this goes to plan.
Wow, 10x? What are you going to do with all that money, Jono? Never work again?
Probably not. Reckon I'd get a bit bored without some work. What I want to do is give myself a UBI.
A UBI?
Yeah. Universal Basic Income. In a sensible world, government would give us all one. But this isn't a sensible world, right? So if I can squirrel enough away, I can pull it from my investment income. Just got to start early, which I did, invest smart, and let compounding do its job. 50k a year ought to do it.
Only 50k? That won't go far.
Ah, not on its own. But that's not the point. Point is, I can work on my own terms then. Do something I like, work part-time, refuse to work for large organisations.
I get the first two, but what's wrong with large organisations?
What's wrong with large organisations? I'll tell you what's wrong with large organisations. It's stupid.
Stupid? What's the stupid?
Well, Kev, here's how it works. Many organisations, they start sensible. Everyone knows everyone and they go to the trouble of bringing good people in and pushing stupid people out. But as the organisation grows, at some point, sensible people can't keep the stupid people out anymore.
Can't you just hunt the stupid down and remove them?
Well, you can, Kev. You can. And our mates who give us a lift into space in Lecture 7, they do exactly that. But not every organisation is so careful. And once the stupid gets in, stupid multiplies rapidly, setting up structures to protect and resource itself. When a certain threshold of stupid is reached, start hearing silly words like deep dive and champion and circle back and touch base every second sentence, and see endless, pointless meeting invites start appearing in your calendar.
Pointless meetings?
Yeah, pointless meetings. Stupids love them. They'll fill every minute of every day with them if they can, all week, all year, for 2 reasons. First one, hearing their own voice makes them feel important. But second, this is the crucial bit. Meetings don't exist to do work. Meetings exist to make work. And that's the double whammy, because making work, it's easier than doing it. Then you just lump some of that work on the non-stupid, who were smart enough not to want to come to your stupid meetings in the first place, and then what's left over enables you to justify bringing in even more stupid people to help take the load, attend all your meetings, and get you promoted to a higher salary.
It's truth, Jono. Sounds like cancer.
It's exactly like cancer, Kev. It's a good example. And because the stupid soon outnumber the sensible, you can't fight them. And then they kill the host and kill you with it.
That sounds terrible.
It is, Kev. It's my worst workplace nightmare. And so that's why one should get financially independent as rapidly as possible. It means you can escape the stupid, become stupid independent, so to speak. Life's so much better that way. Anyway, that's the plan.
Sounds like a sensible plan. Maybe I need to get busy on something like that.
Yeah, Kev. Got to get ahead of the curve on this stuff. Think about it early. It's what being smart's all about, right? Welcome to 2022 and the 3rd year of COVID. This is Lecture 0 of PHYS2111 Quantum Physics, what I've taken to calling the Let It Rip edition of the course. In this Lecture 0, my aim is, hopefully without too many takes, to get through just the broader generalities of the course. A lot of the specific detail will be either in the course outline or on the Moodle site. What I want to do here is just sort of summarize the overarching picture of that, and in particular get a little bit down to the specifics of my half of the course. Probably the best place to start is by introducing myself. My name's Adam. Feel free to call me Adam as well. I really like to run my courses in a very informal way if I can. I'll be teaching weeks 1 to 4 of the course. You might see a little bit of me in week 5 as well. If you need to find me on campus during the course, I live in the old main building. My office is G57A. It's behind a locked door, which means I can be a little bit tricky to get to, but if you have an appointment, I can get you into that area. I have a pretty busy schedule because I have an admin role and a research role in addition to teaching. So I don't mind making appointments for lots of convenient times. That's fine. Email me if you want a consult appointment. But the best time to find me is probably right after the Thursday workshop class, which is going to be 3 to 5 on Thursday afternoons. I'll talk more about that class in a moment. At that point, we'll have an empty theatre. There's no rush for me to run off to other tasks aside from going home and having dinner. And so if you have burning questions you want to ask, that's probably the best place to get me. The other 2 really good ways to contact me are by email. My email address on the UNSW system, adam.mikulich@unsw.edu.au, works. I get emails from it. I just don't use that address most commonly, and the most direct way to get me is via my Gmail. My UNSW email just forwards to it anyway. I just like Gmail servers a bit better than UNSW servers. They work a little better, particularly on the road. So email works really good. Some of you will also know that the Physics Student Society set up about 2 years ago a Discord server, and there's a section on that Discord server for this course, and I pretty regularly pop on there and check and interact in that space. So if you want to post questions on there as well, I'll be floating through occasionally and dealing with them. So before we get into specifics of the course, I might just talk a little bit about what I do. Could broadly be described as an experimental condensed matter physicist with very broad interests. So my early background in this subject was in quantum effects in nanoscale devices, so taking electronics, scaling them down to a size where the quantum mechanical properties of electrons start to become important to the function of those electronic devices. I worked in that field for probably 10, 15 years, something like that, and one of the interesting things in science is that fields move at the same time as you move through them, and the interests diverge into different places. So I started in that subject, and it was very curiosity driven, and eventually became what now is mostly seen as parts of quantum computing. My interest sort of shifted in a slightly different direction. I started becoming interested in bioelectronics and biophysics more generally, and whether you can start to use these nanoscale electronic devices to understand biological systems, which also in principle sometimes show quantum mechanical behaviors, because quantum mechanics is a fundamental part of chemistry. And so a lot of the research I do now is more in the domain of looking at electronics that are compatible with biological microscopy systems, so that we can start to understand how things like protein machines work, how to do readout for biological computation and those sorts of things. I think that's sort of an interesting background in some ways, because it gives me a bit of technical experience on the quantum mechanical side. That means that I sort of understand the subject, but also a bit of a breadth to this sort of experience of quantum mechanics, such that it makes it a bit easier for me to explain, and it's probably the main reason why I really enjoy teaching first courses on quantum mechanics. So how I normally run with lecturing in pre-COVID times, I made a decision very early that I sort of hated PowerPoint. I sort of saw it a little bit like a prison, because you have this form where typing in equations and text takes a lot of time for me to do, and it's not very compelling for you to read. It was kind of a little bit of a hell. So I evolved to this point of using some mix of PowerPoint slides, which are really great for showing pictures and graphs, and sometimes even just summary points and more complicated equations. But what I also really like to have is the ability to get deep into the maths and do that as sort of a stream of mathematical consciousness written on a blackboard. And so the way I normally run in most of my courses is some mix of PowerPoint slides and writing on a blackboard. And writing on a blackboard has the problem that students often sit there and spend all of their time scribbling down what's being written on the blackboard. There's the famous saying that a lecture is a time for material to go from the lecturer's head, from the lecturer's notes to the student's notes, passing through the brains of neither. And that's kind of true. So the one way I sort of solve that to some extent is to provide written copies of all of my notes that I use for anything that I write on the blackboard, so that you don't actually have to copy anything down. You have everything that I have when I rock up to teach in the course. Okay? So when you have a look on the Moodle site, you'll notice that there's downloads. There'll be downloads for slides, and there will be downloads for notes, and those notes will be in PDF form, and they will be very detailed and absolutely everything that I have. COVID became interesting because a lot of people saw it as a hellscape. You know, I can't go to a lecture theatre anymore. I can't stand at the front and just talk, and had to go online, and either found that intimidating or not much of a challenge or whatever, did the bare minimum they could do to run with it and went from there. I actually saw it as something of a giant opportunity in some respects. One of the things that I like about lectures is that you get to talk about the subject. One of the things I dislike about lectures is that every year I get up and I say more or less the same thing, and it probably works out that 95% of the time I'm talking at a room that's listening to me, and there's only maybe 5% or even less of the time that's meaningful interaction between me and the class. And that can reasonably be done by recording it once, doing it really, really well, and then using the time that I save from doing that in order to give a separate interactive session that I can focus all of my efforts on, okay? So the way I'm going to run in this course is all of the lectures that I'm going to give, and there will be, you'll see on the website there's actually 13, but one of them is sort of an optional extension lecture that you can watch at your leisure later on. So there's basically 12 lectures in my week, my 4 weeks of the course, and all of them are in a YouTube streamable video format that looks a little bit like this. So what you will have is video of me giving the lecture, you'll have all of my slides, and you'll have essentially the equivalent of an electronic blackboard where I will do the maths. And much like I did in my old lectures, I have notes that underpin what's written on that electronic blackboard that are far more detailed than what I put into the actual lectures. And so you'll have copies of those, and so you'll have all the materials that I have for the lectures plus the live stream of lectures, okay? These will go online in advance in an asynchronous format. So the idea is that you can watch them whenever you like. And so when I talk to my past students, I've had everything from students deciding that they're going to binge watch the week's videos in one hit. So they'll just sit down and stream all 3 hours of that week's videos and get it out of the way so they can move on to the other parts of the course and other parts of their studies. Or some of them got to the point, because I usually cut each of my lectures into 2 half-hour halves just to make them a bit more digestible. There was some who would just watch, you know, half an hour in the morning, half an hour in an evening, and just work through them in the week in little snippets and fit them around other things just so that they could chop up their day. And it's completely up to you how you want to do that, right? If you need to fit it around a job or fit it around other studies, the nice thing about this online asynchronous format is that you can take in the material anytime you want. If something goes over the top of your head, you can slow down, rewind, watch it again. If something's really simple, you can move through it a bit faster. It enables you to take my lectures at your own pace, and if you want to go back and see them again right before the exam, you can do exactly that as well, okay? Then around that, what I've tried to build is a framework of a course that has a little bit more interaction in it. So I'm going to do this year as well, because we're sort of going back face-to-face on campus. I want to get some synchronous live time back into courses compared to, for example, 2020, when things had to be 100% online. So the format for my half of the course, which is weeks 1 to 4, will run a little bit like this. In each week, there will be 3 video lectures. They're asynchronous. You can watch them in your own time. Your responsibility is a little bit to keep up, though. If you sort of let that just drift off, you need a little bit of discipline here, because it's no one going to be beating you to turn up to class on time. If you let them drop into the background, you won't be able to stay up to all the other parts of the course, and it will make things rather difficult for you. Okay. In each week, there will be a weekly quiz. And that weekly quiz will close on Wednesday afternoon. And the reason why it will close on Wednesday afternoon is that everything is being set up for the Thursday session that I will talk about in a moment. And the session has to be on Thursday simply because of timetabling demands. Last year we ran it on a Friday. And we'll sort of just play around with the timing so that we can work around this. The quiz itself is a weekly quiz. I have it as a formative thing. So when we talk about assessment, I guess you can see 2 forms of assessment. There's formative assessment and summative assessment. Formative assessment is basically what I consider the opportunity to do things that look like assessment in a way that has safety built into it so that you can fail and it doesn't cause you problems, right? So this is where you get to make your mistakes to learn from so that you get better at the course. And then summative assessment is basically, well, did you actually learn something or not? It's kind of like the final exam where we go, do you know this? Do you not know this? And so forth. It's good to build a bit of both into the course, and particularly early in the course have sort of formative assessments which give you sort of that ability to make mistakes and learn from them. And so I'll talk a little bit more about how I want to run those quiz aspects of the course later on. But just to preface them quickly, they're not designed to maximize your marks. If anything, I've designed them so that you're encouraged to make mistakes. What I want to do is use these so that you get a chance to interact with material and I get to watch you make those mistakes and also tell me where your struggle points are. And then the idea behind that is that I can design the rest of the sessions involved in the course to help you get through those points that you don't understand very well, with the aim that eventually when you get to your summative assessment at the end, you actually have made all your mistakes, learned from all your mistakes, and hopefully you get everything right? Because if you all do good in the course, then I look good because I've got a really good class and I've obviously taught them well, right? If you look good, I look good. So this will sort of culminate in what I've called, pardon the bad pun, Physics Thursdays. And what we've tried to do here is design the class structure so that there's a really good incentive to come to campus and have a critical mass of components of the course to help you do that. So rather than have, one thing scattered here, one thing scattered there, come in, switch to the subject, leave the subject and not really interact with it, kind of tried to condense 3, maybe even 4 hours into one afternoon where we really build this together. The afternoon will look a little bit like this. There'll be a tutorial that will run on Thursdays from 1 to 2 p.m. And all of these classes on the Thursday afternoon will be hybrid. Our demo unit has worked quite hard over the summer to set up some really cool hybrid technology so that I can teach from the front of a classroom almost as well to people sitting in the room as I can to people sitting at home watching the live stream, okay? So there'll be a live option on campus. Now, you'll have to ignore what your timetabling system tells you here. I've managed via some devious means to get my hands on the physics lecture theatre for the entire Thursday afternoon. And what that will mean is that all classes are in there. It's an enormous room. We should be able to fit in there with reasonably good spacing. It's got plenty of space at the front so I can set up hybrid technology setup. So this class should work just as well for people who can't make it in and want to sit on the Zoom stream instead of coming to the room, so you can do either. The tutorial will be first, and so Dominic Jones, who will be the tutor for this course, will spend an hour working through various aspects of, parts of the weekly quiz, ideas from the weekly quiz, and so forth, okay? You'll see how that works in the first class, and you'll get used to that fairly quickly. There'll then be a 1 hour break, give you a bit of time, a bit of time to think away, go off, you can get a coffee, sit in the grass, get some fresh air, whatever you like. And then I will have a workshop class. It's 2 hours long, Thursday, 3 to 5 p.m. Same deal, hybrid class. So there'll be a live version in the physics lecture theatre with Zoom stream for people online. And it's going to be a semi-structured session that'll focus on, again, coming back to the weekly quizzes and the weekly problems, but from a slightly different perspective. Rather than trying to work at sort of some of the mechanistic details of these things, it'll be trying to focus on tricky points, questions, that sort of thing. Plenty of chances there for discussion to go off into directions that are kind of interesting, and some of that will be motivated by the things that emerge for me from the weekly quiz, and that's the reason why the weekly quiz closes on Wednesday afternoon. That gives me Thursday morning for me and Dom to have a look through all the things that come in, so we can work out, they're not getting this is what we need to work on today, or, oh yeah, they all get this thing, it's perfectly fine, we don't need to waste time there. It means that what we can do is put maximum effectiveness into one afternoon, so that we clean up all the things that you're not getting from watching the video lectures. Finally, on the Thursday afternoon, and sometimes this workshop class might finish a little bit early, and we can use that time as well. I'll have a little bit of a Q&A session because physics lecture theatre will be free, and so that will be absolutely no structure at all. There'll be nothing new. It won't be recorded. It's just an opportunity for people who come to the live session who want to stick around and ask me questions. And I might see if I can do this hybrid as well. I'll trial it during the term. It didn't work so well last year, but I'll see what I can do. Just to stick around and ask random questions. And so this can be really useful. The class last year actually kind of enjoyed this, and often it got to the point where I said, I'm going home now, because we could have sat there for hours. I'll stay until either everyone's done asking questions or my stomach starts growling and it's time to go home for dinner. Okay? And so that will pretty much bring most of this course into Thursday afternoons, and we will repeat that week on week until we get to the end of my part of the course. Okay, so for online support, there's going to be a very big onus this term on some amount of people coming onto campus and being able to support people who are not able to come to campus. So I actually really like to have multiple streams for people to get at me. And one thing that I really like to do is, rather than take lots of questions by email, which is usually just a very one-on-one thing that most people don't get much benefit from, is to try to spread that out. So I'll run the usual Moodle forums that you're probably used to from first year from your first year courses, but I also tend to run on the Discord server that the Physics Student Society set up. There's a link for that. I'll check it's current. I'll make sure that the current link goes onto the Moodle site so that you can all get in there. And then you should be able to sign yourself in, and somewhere down this left-hand side you'll see PHYS2111, and that's a place where you can interact. You can talk to each other, I can talk to you. And the benefit of all of this is that if someone asks a question, everyone gets to see my answer to it, which means that instead of me having to send 96 emails, I can just send one message to here. And you can also answer each other's questions, which is actually a really good way to learn the subject. One of the big cruelties of being a physics lecturer like me is that often I find I learn more in a course than you learn in a course, and mostly it's because I have to work out how to explain it, and you just have to receive it for the first time. And that having to pull it together and explain what it is that you know often makes you understand it better. Okay, so feel free to answer each other's questions in here. It's a really useful way to learn and interact and get to know each other as students as well. The Moodle site looks like a fairly usual Moodle site. You can delve into it later on. It'll have the usual announcements section at the top, which is where you'll find all the things related to the technical detail of the course. There will be a course outline posted up in there. There will be exam procedures, which I'll talk about later in the course. And then further down, there will be my half of the course, and it will have a few sections in it. The first one will be my notes and materials, and that will be where my slides and my PDF notes will all be, and you'll be able to get them by lecture and pull them out, download them, do what you like with them. There's a section in here that I like to call AdFlix, which is basically where I pool all my video lectures together. It will also have course learning outcomes or lecture learning outcomes by a lecture. So for each lecture, you'll have an idea of what it is that I expect you to take away from that class, so that you know what it is that you learn, and those things will motivate the way we design the quizzes. They'll motivate the way we design the Thursday classes, and ultimately they will motivate the way we design the exam. Okay, so a lot of students ask me in courses, well, what's examinable? For me, it's really easy. I just go have a look at the specific learning outcomes for each lecture. That will tell you what I intend to examine, because what I tend to do when I write the exam is look through a subset of those learning outcomes and build questions around them. And if you can do all the learning outcomes, then in principle you should be able to pass or better in the course. Okay. There's a section in here where I will put up tutorial questions and solutions along with past exam papers for you to try for yourself. And then down here is a little just Moodle forum for asking specific technical questions about my part of the course. Okay, fairly typical Moodle. I'll let you find your way through it. Second half of the course is going to be taught by Dr. Peter Rees. He'll have a slightly different approach to teaching, and so I'll let him provide some details on how he's going to operate when week 5 gets a little bit closer, because he'll know the specifics of that a bit better than I do. Okay, so one of the things that comes up in any course is textbooks, and I have interesting philosophies on textbooks. Textbooks are nice as a guide. They can often be very hard to learn from, depending on the nature of the book. The official textbook for the course is this book, Introduction to Quantum Mechanics by Griffiths. It has all of the technical content for the course, but I find it has it in a much more technical standard than is good for teaching as a first introductory course to quantum mechanics. And this is, for me, one of the places where quantum mechanics gets kind of difficult. A lot of the first times you come in, the textbooks are all very imposing, and it's difficult to work out what's going on, and then, you know, after a while you find yourself deep into the subject and realizing that you can't swim very well. And so a lot of my job in this first course is to try and get you through a lot of the difficult aspects of this by really simplifying them down, so that later on when you come to seeing them in their more technical form, you go, well, it's just this, I learned this in second year, and then away you go. Okay. From that perspective, I consider this to be the unofficial textbook for the course. I really like it. It's a book by Susskind and Freeman called Quantum Mechanics, The Theoretical Minimum. You'll find it in a lot of bookshops now. Kinokuniya in the city has it, so do a few of the other bookstores in the city. And the nice thing about this is this book costs you, well over $100. It's a traditional university textbook. This one is brand new, usually $20-25. If you can get a second-hand copy, you can probably pick one up for 10 or 15. And it's a nice, accessible, very easy readable book. And I've kind of designed my half of the course around this book. And to some extent, the general flow of the whole course actually in some ways follows this book. And so you could almost put this book alongside this course, and if you get the whole thing, then you really do sort of get quantum mechanics, at least at a beginner's level, and it sort of walks you into higher years of the subject with a good intuitive understanding of how things work. Okay, don't need to get neither, but if you had to choose one or the other, probably choose the one on the right. It's a nicer book. Don't tell the publisher of Griffiths that I told you that though. Okay, so rough plan for my part of the course. There's 4 weeks, and we're going to work through topics that look a little bit like this. We're going to start out with quantum measurement and logic. And so straight up you'll spot that I'm probably taking a very big detour from what you might have seen if you did any aspects of quantum mechanics in first year physics. So in first year physics you come in and you start to look at wave-particle duality, which is a concept I absolutely completely hate, and I might talk about why I hate that in the lectures. And then you get into, uncertainty principle, and the first time you see uncertainty principle without good mathematical framework behind it, it doesn't really make sense that well. And then you might see Schrodinger equation, and again, that's something that just magically pops out of the air, and that doesn't make a lot of sense. And I've never really liked building on that, because it's kind of like trying to build a very giant castle on a foundation of sand. It just falls over because it's weak foundations, right? So the way I like to teach quantum mechanics is just make a clean break at first year and start trying to build a very solid foundation, and a very solid foundation from a mathematical framework, because one way to see quantum mechanics is essentially as applied linear algebra. Okay, and this is why when students say, "Oh, can I get an exemption to come into this course?" I'm less worried about whether they've done first year physics than I am about whether they've done first year maths, because the really crucial thing to understanding quantum mechanics is to have a very good grounding in linear algebra. So if you want to get a little bit of head start this term, before we even get to week 1, go back and do a little bit of a refresher on linear algebra, matrices, vectors, that sort of thing. They're going to be absolutely crucial to the course. So we'll start talking about quantum measurement, logic, and then start introducing some concepts that connect quantum mechanics to linear algebra from the perspective of a simple quantum mechanical system that is, basically a spinning object where the spin points either up or down. And many of you will be familiar with up and down from electrons in chemistry, okay? And we'll look at how to represent, states as vectors, and talk about things like projections and how to calculate probabilities, and you'll see really good connections in their first week to just basic concept in linear algebra. Then build from there to eigenfunctions and eigenvalues, so you'll see why eigenfunctions and eigenvalues are really interesting when you learn them in a linear algebra course. There's a reason why we ask them to teach you this. Concepts like expectation values, and start building up a real picture of quantum mechanics for a very simple system, which is simply just an electron spinning on its own axis. Okay. In week 3, what I want to do is start to get from what happens when you have one spin to what happens when you have 2 spins, and start looking at a really interesting idea in quantum mechanics for the first time, which is that of entanglement. It's interesting because there's a lot of sort of mysticism connected around entanglement that ultimately, when you understand it, is actually completely crazy. And so some of what I'm trying to achieve in week 3 is just to demystify the subject a little bit for you. Some of it also is that it has direct connections into the things that a lot of people who do quantum mechanics now are very interested in. So quantum information, quantum computing, those sorts of things. Understanding entanglement is pretty crucial to that. And then where we'll go in the end of week 3 and into week 4 is taking the mathematical framework that we've built just from the idea of having a spin up and spin down, and extend that out to systems that have a very large number of dimensions, right? So an example would be a particle in free space. And when you do that, all of a sudden a number of things start to make sense. Those are things like uncertainty principles, where Schrodinger's equation comes from. All these sorts of things make a little bit more sense when you pull them out from a much simpler linear algebra based version of quantum mechanics. And so what will happen is Peter will take over in week 5, and then he'll start to move from there into the more function version of quantum mechanics, and look at things like Fourier analysis and those sorts of things as part of this course. Okay, so that's roughly where we're going. So to the assessment, there's going to be, and there's a typo on this slide, there's now three key assessment tasks in the course. There will be one component which is quizzes and assignments. It's worth 20% of the course. They'll be divided up into a number of small tasks that happen across the term. Some will be in, 10% of that will be in my half, 10% of that will be in Peter's half, and we might take somewhat different approaches to that. My approach to my 10% will be entirely formative, okay? And so what I mean by that is that I'm basically going to allocate marks to give you the long version of it, demonstration of ability to engage meaningfully with the material, or in one word, what I like to call an honest attempt, rather than being correct. Okay, so the focus here is I want to see you attack the problem for you and not get someone to help you with it or look it up on the internet or find the answer on Chegg, because that's not what this is about. This is about you engaging with that question and having the struggle with it and finding out whether you understand it, right? Now, one of two things happen there. You understand it, you get the question right, and you still get the marks. Or you don't understand it and you don't get the question right, and you still get the marks because, in my view, you've made a solid attempt at it. And the reward, or what I'm trying to reward there, is the attempt, because it helps me understand what you do get and what you don't get. And by understanding what you do get and you don't get, I can work out where to focus the attention on the Thursdays, so that I can correct the things that people are not getting, with the idea that by the time I get to the end of the course, all the students who already know it, well, they already know it at the end of the course. All the students who are struggling, I get them to know it by the end of the course, and everyone does well in the final summative assessments, okay? So really want you to focus in these parts on being completely honest about it. If you cheat it, you're only cheating yourself, okay? There's a lab component in the course. There'll be more on this in the Moodle, and I will talk more about it in the next slide, because the one challenge we're going to have this year is how we run lab in a let it rip COVID environment in a way that keeps you safe and keeps us safe and keeps the labs actually running. And what we'd really like to do is keep that running, because it's almost impossible to learn lab skills in an online way. You really need to interact with equipment, you really need to be getting your own data, and it's just a challenge for us to work out how to do that as safely as possible, so that you don't miss that experience, but you don't get sick in the process. Okay, so I'll come back to that one in a moment. That's 20% of the course. And the last one is a final exam. We've decided in the last year or so to remove the midterm exam, mostly because there's a little bit of redundancy, and also because the terms are so compressed now that we sort of just examine you on something you don't really know yet, and then examine you on it again at the end of the term, and it doesn't really make a lot of sense. Just from a pedagogical sort of learning standpoint, it makes more sense to just give you exam-like questions during the term that you can interact with. And a lot of the quizzes and weekly quizzes and problems will entail some exam style questions in there, and then at the end of the term we can put everything down to, now do you know what's going on? Okay, so this will be a 2-hour exam in the term 1 final exam period. It's going to be an online exam like it has been in past years, so our idea is that you will download the exam, do the paper, and upload the exam again. Some of you who've done higher year subjects in the past will be familiar with this now. Actually, if anyone who did higher PHYS1B special last year will be familiar with it, because I played the same game there. And the one small difference that we might have this year is that we may have to do this in the new exam platform in Spira rather than Moodle, and I'll give you some more details on how that's going to work later. Okay, so that brings me to COVID measures for T1. And so if I think, just in terms of how to run the course, a major priority for us this term is going to be, how do we run with the university's desire to go back to face-to-face classes, and you know, we really need to do that at some point, because there's a lot of missing education that happens if you're only doing things online, but do that in a way that is safe for students and staff alike, right? And the one place where this is going to most matter is the lab, as I mentioned before, partly because you're in the lab for a long time, there's a lot of people moving around, and also if everyone starts to get sick, then we end up having to cancel labs, and that removes your ability to do labs, okay? Now, we're all physicists, we sort of understand kinetic theories of gases and diffusions and diffusion and all the rest of it. And so if you think about it just from a physics risk management perspective, scientifically, what's the biggest risk to the lab program? The biggest risk to the lab program is having COVID-infected people in the room. And if you can minimize that, then all the other provisions work better, right? In the ideal case, if there's no one infected in the room at all, the provisions are absolutely invincible, because there's just no virus that you have to worry about. So for us, our thinking is the primary concern is to create an environment where you don't feel the need to risk coming in because you're going to adversely affect your marks by not coming in. Okay, so a lot of the way things are structured this term is to essentially provide a safety net so that we can still run classes face to face, but if there's a risk that you're going to come in and make people sick, just don't come in and we will work around you and do that. Now, there's a little too much detail in that for me to get into here, otherwise this video is going to go for like an hour and a half. So there'll be a post on the Moodle site sometime in a week that will spell out exactly how we're going to do this, and there'll be follow-ups on that as well, okay? But just to summarize, at least for the lab component, what we're going to do is we're going to have you do 2 labs. We've really gone very flexible on the timetabling of this for 2 reasons. One, what we want to be able to do is minimize the number of people in every class so that we can make sure that we're as well spaced out as possible. And we want to be able to use the timetable in such a way that for every class that we have a spare slot. So if a day comes and you go, oh, you know, I've got a scratchy throat, I'm not going in, we can plonk you into another class somewhere else once that's sorted out so that you can make that requirement then, okay? Maximum flexibility in the timetabling is one of the things we want to do. The other thing we've done is relaxed the marking requirements a bit. There's 2 reasons for this. One is we don't want to create the perverse incentive, which is that, you know, I have to go in even if I don't feel well because otherwise I'm not going to get my marks. Okay, and so you'll see about the details on this in Moodle. We've tried to make it as easy as possible to get through with a real focus on learning and just being able to come in and get that experience of dealing with equipment face to face. The other aspect of that is it also provides us with the flexibility to adapt through the term, because it's really hard to know at this point how it's going to go. Things could go really, really well and, you know, all the classes keep going and nobody gets sick and, you know, it could be quite nice. We could just go back to normal. The exact opposite could happen. We don't know whether it's going to happen, is that, you know, a lot of students get sick, a lot of the lab staff get sick, we have to cancel the labs, and then we have to work out how to deal with all the missed labs so that we can make up the marks. And so what we've tried to do is structure this as flexibly as possible, and we'll try our best with whatever comes along during the term to get everyone completed through that lab component. And essentially it's probably going to end up slightly formative in the end, in the sense that as long as you've done something that meaningfully interacts with the lab component in some way, you'll get your lab marks for that component, okay? And then there's one other administrative thing that I want to mention, which is that the university is providing mechanisms for students with medical circumstances that are sufficient that they feel they need a medical exemption to apply to have that. That's being handled centrally through Equitable Learning Services, so that there can be sort of a way of working out what is a solid case for making very special measures and exemptions and what isn't. So we haven't been given the discretion to just go, no, you can't do the lab component, you can opt out. But if you feel that you've got something sufficiently severe that you shouldn't be coming to campus, then talk to Equitable Learning Services, have a talk to the lab manager, Tamara, about that, and we'll do everything we can to try to enable you to make your lab experience this term as safe as possible and still get through the course, okay? And then one other thing I'll mention is for cases where you get infected with COVID and have to take time away from campus or have to isolate under the New South Wales health rules, those will be handled through the normal special consideration process, probably with quite a bit of leniency this term. And so in cases where that happens, you should lodge a special consideration case in the way that you normally would. But on top of that, remember that we do have the flexibility for you to miss classes. So if you do feel like it's a risk for you to come into campus of infecting other people, let us know and we can arrange that around the special consideration system. There'll be more details on this on the Moodle site. Okay, so I just want to finish up this video and stop it from getting too long with a couple of tips for success in this course, just so that you can see them coming in advance and be prepared for it. So the first one is that quantum mechanics is a conceptually very difficult course, and it's quite different to other courses that you do in higher year physics, particularly at second year, for example. So, I mean, to give you my favourite example as a counterpoint is PHYS2111 classical mechanics. Classical mechanics, the concepts themselves are not very difficult. You have objects falling, you have them rolling, you have whatever. What you learn in that course is more advanced techniques, mathematical techniques for solving mechanical problems, right? So you get beyond the approaches you learn at first year, which become rather difficult very quickly when you deal with more complicated mechanical problems, and you learn approaches like the Lagrangian approach and the Hamiltonian approach that help you mathematically or use mathematical power to break big problems. Concepts there are easy though. Quantum mechanics is quite the opposite. The mathematics here is rather simple. In a lot of cases, we're just multiplying vectors or multiplying a vector by a matrix or calculating a probability. The difficulty comes in how you connect the things that you do in linear algebra to what their meaning is in terms of the physical system. And that requires a somewhat different approach where you need to spend a little bit more time sort of thinking about how to make the connections between the material and, well, the mathematical aspects of the material and what it actually really means. And so it's very worthwhile keeping a little bit of time aside. When I was a student, I used to have to take the train for well over an hour to and from home to campus, and I'd spend a lot of the time staring out the train window, more or less meditating on, you know, what does this mean from the lectures? Why are we using a vector? What is actually really happening when I multiply a matrix by a vector? What does that get me? Those sorts of questions, and I'll talk about those a little bit in the lectures and the workshop classes. But if you don't want to take it from me, then take it from one of my past students. I won't read the whole quote out, but they will say exactly the same thing. That once, if you invest that time in thinking about what's going on in the course, then you'll not just learn it better, but you'll probably enjoy it too. There's some interesting questions that come up there, and you should, when you can, speak to each other about those too. And so that little hour between the tutorial and the workshop session might be an absolutely ideal time for you to just, you know, go have a coffee with a few of your friends from the course and just toss around some aspects of this in between the two classes. There's two last points I want to add on to here. One is that quantum mechanics is a very, very complicated subject. It's complicated from the mathematical side sometimes, and it's complicated from the philosophical side sometimes as well. And I'll come back to the philosophical side for a moment, in a moment. But I sort of really like this quote from Richard Feynman here, that anyone who claims to understand quantum theory is either lying or crazy. And it's true because there's lots of what I would call non-intuitive aspects to quantum mechanics, and how non-intuitive they are varies with how long you've been in the subject. So if you're very new to the subject, lots of things will seem really completely weird and strange. And then if you've been around in the subject as long as I have, I'm now probably getting on beyond 20 years of dealing with quantum mechanics, both as a student and a researcher and teaching initial quantum mechanics. There are things which, you know, even people outside will say, oh, you know, this is spooky or non-intuitive or whatever. And I just go, no, it makes complete sense. All you got to do is just put your faith in the mathematics and accept that this is the way that the world works, okay? And so you won't always understand it, and what he means by understand it to some extent there is just have it make intuitive sense, because there will always be this. It's to some extent just a matter of learning to become comfortable with it. And so this is where I want to finish on my final warning for the course, and it may be received by some people as a slightly controversial point, but there's a big school of quantum mechanics that actually believes in exactly this point, and it's called the shut up and calculate school of quantum mechanics. And the basic idea is that it's very easy to get trapped in all of these philosophical ideas of quantum mechanics that actually don't really go anywhere, because all you sort of do is think yourself around in circles. And some of these things end up looking a little bit like the chicken and the egg problem. So the chicken and the egg problem is, the chicken lays the egg, but then the chicken comes out of the egg. And so which one happens first? Is it the chicken or is it the egg? And there's no real solution to that problem in the end, right? Because you can't have a chicken without the egg. And of course, the chicken is producing the eggs, and there must have been, a first chicken, and that first chicken must have come out of an egg. So after a while, you just go round and round and round in circles, and you can literally end up crazy. There's Nobel laureates who've, you can find them online, who've more or less just gone down this rabbit hole of madness, having done, something really interesting in quantum mechanics and got stuck on these philosophical problems and gone off. And it's dangerous because at the end of the day, you really still need to kind of do something, right? Otherwise, you just end up just retreating, more or less, like this, up into a temple in the mountains and just not doing it very much until you die. And most people want to come through a quantum mechanics course, learn some quantum mechanics, go out, get a job, earn some money, buy a house, have a good life before they die. And spending some of that time thinking about these philosophical questions is kind of fun, but you still want to be able to do something. And this is where this shut up and calculate school comes from. Sometimes you just need to put your faith in the maths and do things with quantum mechanics. And some of these problems are fun, and we'll talk about them in the course, particularly in week 3 when we get to entanglement. And we'll even defuse some of these aspects of this. But in the end, I want you to really be careful not to get completely stuck in the logical disconnects that sometimes happen in this subject, because they're unending. There's no way to escape them. Sometimes you just have to go, that's the way the universe works. I'm not going to understand it. I want to get stuff done. I'm going to go and get stuff done. Okay? So I think that's pretty much a full introduction to everything in the course. There'll be more details on the Moodle. If you've got any questions, feel free to email me or get in touch on the forum or send me a message on the Discord. And hopefully I'll see you at some point in week 1. Enjoy.